Well, hi everyone. A little bit different video content today. I'm going to cover the U.S.'s planned upgrades to the 450 Minuteman III missile silos that are currently in use. Now, I'm going to relate this to my background in civil engineering and construction because I think there's a lot of interesting aspects to this whole project. In fact, it's one of the biggest programs the U.S. Air Force has ever undertaken. Current cost projections are around $130 billion. There's multiple aspects of this upgrade program, a very complicated design and procurement process, and a lot of uncertainties about the construction that I'm going to get into here in a bit. So what we're referring to is the new Sentinel program to replace the Minuteman III program. Now the Minuteman III goes back, the earlier iterations of the Minuteman program go back to 1964. And the build out was completed by 1967. So to give you an overview of the ICBM missile program for the United States, there was initially the Atlas and Titan I missile. The Titan I relied on cryogenic liquid fuels, so those had to be onboarded immediately prior to launch. Was a very dangerous and time-consuming operation, and it really limited the amount of time available to launch a retaliatory strike. Then we have the Titan II. I recently toured the Titan II Museum in Green Valley, Arizona. It was very interesting. And then that gave way to the Minuteman I program, and then later iterations, Minuteman II, Peacekeeper, and now Minuteman III. Now what we're talking about with this program upgrade, it's to enhance and extend the U.S.'s capability for ICBMs based on land. So it's one leg of the so-called nuclear triad, the other two being submarine-based with the 14 Ohio-class submarines, and the other bomber-based with a total of 46 B-52 bombers and 20 B-2 bombers. In fact, at Whiteman Air Force Base about a week ago, they did their elephant walk where they got 12 B-2 bombers off one after the other in quick succession. It's quite a sight to see. So what we're talking about is we have individual missile silos. There's a hardened concrete and steel cover that retracts at the time of launch to expose the missile. It's a multi-stage solid rocket fuel missile. So the Army Corps of Engineers was responsible for managing the construction of these missile silos, and there were a total of 1,200 built. 200 of those were associated with Atlas and Titan I silos, and then there was 1,000 Minuteman missile silos that were originally constructed, and due to various treaties and upgrades, that number shrunk to the current 450 silos. And you might ask yourself, well, why do we have 450 silos if we only have 400 Minuteman III missiles, and we're going to have 400 Sentinel missiles later on? And that's because it's done to keep the adversaries guessing. They can't be sure that any given silo is going to have a nuclear tipped ICBM in it or not. So they're forced, if they want to make an attack, to attack every single silo. Now the current Minuteman III missiles are located at 3 Air Force bases in the U.S. F.E. Warren Air Force Base in Wyoming, and then you have the Air Force bases in Minot, North Dakota, and Malmstrom, Montana. Each base has 15 underground launch control capsules that act as hubs for fields of 10 Minuteman III intercontinental ballistic missile silos each. Each Minuteman III missile can carry 3 warheads, but it's currently limited to 1 warhead per missile through various treaty obligations, from what I understand. With the upgrades to the Sentinel program, the plan would be to extend the U.S.'s capability in having a credible land-based ICBM deterrent for another 50 years. The first flight of the Sentinel ICBM is expected to be February 2026 and expected to reach full operational capability by around June 2030. And of course, these upgrades are going to take a number of years to all 450 silos. I think the current plan is to have this completed by 2031. That may be rather optimistic, and then have all the silos upfitted to the new Sentinel ICBM by 2036. So what are we talking about with this upgrade program as part of the Sentinel objective? So you have upgrades to computer equipment, communication equipment. You have right now 7,000 miles of copper cabling that connects all these silos to command centers. That's all going to be replaced by fiber optic cables. So there's going to be thousands of miles of new trenches excavated to support this work. Then you have the work that's going to be done at the silos themselves, and then later the upgrade to the new Sentinel ICBM. Here's a map showing the geographic location of these silos. We have Warren Air Force Base in Wyoming. These symbols indicate each individual silo. Malmstrom Air Force Base in Montana, and Minot Air Force Base in North Dakota. So the work has to be done within the footprint of the silo property as it currently exists. So you're going to have upgrades to the entire silo complex. Here's a cutaway of the launch control module, as well as the mechanical support module for the launch control module. And here's a cutaway of the missile silo. Again, you have a steel liner that is surrounded by heavily reinforced concrete. In fact, they added boron to the concrete mix to provide shielding from gamma radiation in case there was a enemy nuclear attack. The silo facilities built to withstand anything but a direct nuclear hit. So the whole design was to support a two-person missileer crew who could get their launch off if needed. So just some model designations. The current Minuteman III is an LGM-30 ICBM, and the new Sentinel ICBM will be an LGM-35A. So let's look at specific improvements to these individual silo sites. And as I mentioned, they're going to renovate all 450 of these silos. So there's going to be a new communication support building. They're going to replace the launch control center, and there'll be upgrades to associated mechanical support systems and backup power generation, that sort of thing, backup power supply. Now, to give you an idea of how old these structures are, I want to show you what a Titan II missile complex looks like. As I mentioned, I toured one in Green Valley, Arizona, the only one in existence. And they cut a hole in the re-entry capsule so that the Russians could verify that it wasn't a viable ICBM through their satellite reconnaissance. And you can peer into the missile silo through that enclosure. And you got the bridge leading to the control room. You've got all this beautiful seafoam green color that was pretty prevalent in the 60s. I understand it's also used in submarines. If you know that to be the case, please let me know in the comments section. And now we're seeing a Minuteman II launch control room. I actually toured one of these. It was at Whiteman Air Force Base. I worked there as a construction inspector the summer before I graduated with my engineering degree. And one of the buildings I was responsible for was the missile maintenance building. So I had early exposure to supporting these programs nearly 40 years ago. So let's get back into the civil engineering aspects of this. The type of construction that was used for these silo complexes is what's called cut and cover. So an excavation approximately 40 foot deep would be performed, and that would get most of your equipment in place. And then you'd have to extend the excavation for the silo itself another 40, 50 feet. I think total depth of the silo is like 80 feet. And that was done either through rotary tooling or clamshell buckets, depending on the material being excavated. And a number of these sites had groundwater, so that the groundwater had to be controlled throughout the life of the structure. I would think they would try and avoid sites that required rock excavation, although this photo seems to suggest that there was some shale or other highly weathered bedrock that they went through. But obviously, if you have hard rock, it's going to be significantly more expensive and take more time to complete the construction. This is a photo of the concrete enclosure around the launch control module, photo of the crane suspending the steel liner for the missile silo. This is what it looks like in place. And then around the steel liner is massively reinforced concrete. And it's the condition of this concrete that they're really not sure of at this point. It's not like they were able to do an extensive investigation with these silos currently being in service. So right now the $130 billion program estimated cost and the current construction timeline is predicated on being able to reuse most of the missile silos at these 450 sites. And that remains a question. I think they'll find as they get into it that it's going to be far more cost effective just to install a new silo, I think. I mean, I'm involved with bridge work and particularly testing of the foundations. And I've talked about this in some recent videos with the needed replacement for the Washington Bridge in Rhode Island or the Francis Scott Key Bridge in Baltimore. And one of the things that officials always float out early is, hey, we could save money and time if we can reuse the existing foundations. And I don't see how that is ever practical. And in my business, all the foundations I've tested, which number in the thousands, have all been new foundations. There hasn't been a single instance of a foundation being reused for a bridge. And keep in mind, these bridge replacements are occurring after 50, 60 years of original life of the first bridge. So the foundations are 50, 60 years old if they were to be reused for another 50 or 60 years. So that puts their use well past 100 years. I don't see it happening. In a similar fashion, if a lot of these silo enclosures are reused, they'll be over 100 years old by the time they're at their end of their service life. So I will be surprised that they'll be able to reuse as many of these silos as they plan to, but we'll see. So as I mentioned, the idea is to have 450 silos and only 400 missiles, so the enemy doesn't know for sure if a given silo actually contains a missile. And these missile transport trucks factor into this effort to obscure what's actually going on. And of course, they're used to actually transport missiles for maintenance and of the missile itself, or perhaps even of the warhead. And you have these transport trucks, they're able to be positioned in a vertical position over the hatch for the missile. And then the missile can be loaded into the transport truck and then the truck lowered and then moved on down the road. Reminds me of the old shell game that you might have seen on a street corner or performed by a magician. Now let's see a video segment of the convoy for one of these missile transports. In order to move things along, I didn't include all the initial lead vehicles, but I'll start here just moments before the main transport truck passes. And you can see there's a lead vehicle and a following vehicle on either side of the transport truck, and they're mere feet away from the bumper of the truck. You've got helicopters flying overhead. They don't stop for anything. All right, so let's look at some views of the current Minuteman III missile. Notice the rusty steel liner. Makes you wonder what the condition of the concrete is behind that liner and even of the reinforcing. If there's significant corrosion of the steel reinforcing, as I mentioned, many of these sites are below the groundwater table, so the sites have to be pumped continuously. So anytime you have water infiltration, if you have cracks in the concrete, over time, the concrete rusts, it expands, it breaks the concrete in tension, you lose the strength of the liner, and I think they may be in for some nasty surprises when they remove these steel liners as part of the silo upgrades. Here's an article I came across, basically outlining the plan that the Air Force and Northrop Grumman has for reuse of the existing Minuteman III silos as much as possible. Mentioned that not all silos were configured in the same way, so that's going to complicate the upgrades. You know, the original construction was sped along significantly by modular design and prefabrication. But obviously the silo itself has to be constructed on site. So here's a question. What happens if the Air Force and Northrop Grumman look deeper within the existing Minuteman III silos and find they're in worse shape than expected? And they mentioned that more intensive testing involving non-destructive testing of the concrete liner just couldn't be performed to assess its condition and strength. They're also planning on reusing the missile suspension systems, so the condition of those may be in question as well. And it says here in this article in Defense News, the government has contingency plans if the silo's foundations prove to be seriously cracked or damaged. That could include remediation work such as patch cracking or replacing portions of the concrete. If a site is too far gone to fix, however, drilling may have to take place for an entirely new silo. And I think that's going to happen way more than they would like to plan for at this point. The other thing that's going to complicate construction is the fact that the Air Force has to comply with environmental regulations that weren't in place when the Minuteman silos were originally constructed. So there's the NEPA rules that became law that require government agencies to follow appropriate environmental permitting and other regulations. The Air Force completed their environmental impact study, which includes opportunity for public comment. That's all been completed. They've issued their final EIS report, but that brought a lot of protesters and activists to the fore. Many of them just simply don't want the U.S. to have any nuclear capability. I don't know how that works when Russia, China, and North Korea are going full tilt with their nuclear programs. One of these activists performed a study, and I'm not sure how accurate it was, but they basically did a simulation to show what would happen with the fallout if each of the U.S. 450 silos had a direct hit from an enemy nuclear ICBM. And of course, you could expect that the fallout would be widespread and extensive. And they estimate an extra 1 to 5 million deaths that would occur through the targeting of Midwest-based ICBM silos. But an interesting ethical point that they do raise is that these people wouldn't be at risk if they didn't have silos in their backyard. And these activists point out that, the high population centers of the East and West Coast would always be a target, but why expose more Americans to the threat of nuclear bombing? And that's kind of an unusual argument. It's like, we expect that the coasts are going to be wiped out, but there's no reason for the Midwest to be wiped out too. I'd be curious what you think about that argument. It is interesting, and I think a lot of these activists are from out of the area. I think there's a lot of indigenous tribes in the area, and I think in general they've supported not only the initial construction but the upgrades as well. So I don't know that it's a situation that outsiders are trying to speak for the locals, but of course they have a broader agenda that they're trying to pursue in this case, and if they're anti-nuclear, it's not going to go very far to supporting these kind of upgrades. So to recap, I think this is a very interesting program. Again, it's one of the biggest construction and procurement programs the Air Force has ever embarked on. I think there's going to be a lot more silos that have to be constructed from scratch rather than reusing existing silos. There's going to be widespread impacts from trenching for these utility corridors. One of the things that people have been complaining about, or people that are against these upgrades, is that they're saying, well, the local area can't support the influx of construction workers, which is interesting to me because presumably the population levels were a lot lower 50 plus years ago when these things were originally built. But that happened in North Dakota during the oil shale boom, and you had people renting spots in people's lawns so they could sleep in their camper, or just temporary construction housing that was constructed. So I think they'll figure it out. It's not the first time that companies have had to build work camps to support major on-site construction in more or less remote areas. When the U.S. installed the original ICBMs, they did it in a way that it could be supported by a nearby population center of at least 50,000 people. And so I think they'll meet that criteria quite readily at this point. And again, the question of how many of these silos can be reused, I think it's going to be very interesting to see how this all plays out. So I'd like to send a shout out to the channel members. I really appreciate your ongoing support. I also would like to send a shout out to those providing super thanks. That's another great way to support the channel. And also I'd like to thank those of you who have liked, subscribed, and left comments to these videos. I really enjoy the engagement. So hopefully you enjoyed this content a little bit different, but again, I tied it into my experience and what I see with the civil aspects of this major project. So thanks for watching. Please stay tuned for future videos.